Greetings, coders. In this video, we're going to look at struct, typedef, and nesting structs. So a struct is a complex user data type that groups together fields or variables that contain similar information or describe a similar meta object. A struct is similar to an object in Java, except, big except, that it only has attributes. It cannot contain functions, so there are no functions in a struct. And there's no other OO type capabilities. To define a struct, we give it the keyword struct, and then we give it the name we want the struct to have. This is similar to a class definition. And then we lay out the properties or the fields that the struct's going to have, and we give it the variable type for each one along with a variable name or a field name. Then to declare an actual variable that uses a struct, we use the keyword struct again and name a struct. So it requires both of these to define the variable. And then we give it the variable name. Here's an example comparing a Java class to a struct in C. Class in Java, we use the class keyword and duct, and then have a string, species name, can fly, can swim, is alive. Over here we have struct duck, and then we have species name, that's a C string, and then bools as well. So pretty similar. Now, on the Java side, we define the values, we create a new duck, and that makes it an object. And then we assign values to the object when it's instantiated. Something similar over here, we must define a variable that will take on the format of the struct. And so we have struct duck, notice both of them, and then the variable name rubber duck equals, and then we give it the values that we want to give it. And then rubber duck can fly equals false. We can set down here the variable values of rubber duck one at a time as well. So when we instantiate or create the struct variable, we can set them all at once. We can also optionally do it one at a time. These are fields within the struct. They have a variable type and a name, and each field must have both of those. In addition, a field may optionally have a value. What this means is not that you can set a value up here in the struct definition, but down here you can optionally give each one a value. It doesn't have to have a value when it's created. Let's move on to typedef. Typedef is another keyword in C, and basically what it does is it allows us to alias one type to a name that's more descriptive potentially, and it makes it more maintainable. The format for a typedef is we take typedef keyword and then the existing type and then a new type name. So if we have typedef int is the primitive type in C, but we rename it to an uppercase I integer. Something a little more descriptive, if we had a field that was weight, we could use int and weight. That will allow us to give something more descriptive. We can also use typedef to alias a struct as a variable type. So the typedef struct, we have struct duck. Everything from struct to here is exactly the same. What we've done is we've added to the outside typedef and then duck to the end. What this allows us to do is only use the duck instead of having to use struct duck to define a structure, similar to the definition before, minus the struct. Now we can also nest structs within one another. This is an example of how to nest a struct, and we will start with the substructure features. And then in the actual struct, what we do is we still define it the same as we did before, and then we do features, physical features. So this nests the substructure within there. The way we would initialize this and define a variable, rubber duck, set all the values, and then we have yellow and 0 as a substructure inside there. Notice the extra braces. And then if we wanted to access the value, we would do rubber duck dot physical features dot color. So just another dot in between to access these sub-elements. Copying a struct works differently than copying an object in Java. When you set a struct equal to another struct, it makes a copy. It does not make a reference. In this example below, we set up rubber duck, and then we set rd2 equal to rubber duck. This makes an actual copy in memory. There are two instances now in memory. There's no reference from one to the other. So if we string copy in rubber duck, physical features.color pink, it will change rubber duck up here. It'll change this value right here. It won't change the copy. So when we print them out, we can see that pink and yellow are both there. We also see that this is occurring within a substructure. And so not only does it copy the top value, but it's able to copy the substructure as well. And then we're able to change it. No references involved. And that's it for this video.